All right, hello everyone. Welcome to our second discussion session for the only discussion section. We are going to cover what we didn't cover with the Skittles project in class. There's still a few code files left that we should explore so you can get the full gist of what is going on in this project. Then I'll hand the mic over to Arunpreet, who will discuss a little bit about exercise 1.
They wave back. That's so wonderful.
Yeah,
Thank you
they're
all.
good. They're good.
Oh yeah.
They're interactive and not fiction. Research joke.
That's a good one.
So we will be talking about exercise 1. Arunpreet will be showing you the bones of the project, how it's structured, things like tile maps, how the characters work, how the input and output works. And then we'll get we'll end with the beginning of the command pattern constructs within exercise 1. There will be more to come with that as we give you the curriculum outline and guide in a few scant hours. So the assignment, if we are successful in our latest revisions, we will get it out hopefully tomorrow. The worst case is Friday. This is how projects have traditionally gone in this class. We've been Friday to Friday. I'm trying to push up the schedule a little bit so we can get a little more time in the final project. But we have a graceful fallback case in case that does not happen. Hey, Nick. All right, are there any questions before we get started? Okay, excellent. I have uploaded the recording from this afternoon. It's in the YouTube playlist, and will soon be in Google Drive. I didn't have quite enough time to upload it to both before I hopped over here. Excellent. Okay. So refresh. This is our project. Anticipation, right? When's it going to happen? Right now. And we are firing off a bunch of projectiles, each of which are randomly colored and skinned. The input for left click is actually processed per frame, per call of the process function within the player calling execute on the projectile, the shoot command. So as long as you hold this down, you'll be getting one of these projectiles per physics process. And then, of course, we have the Nova that we looked at, which brings all of those projectiles that we keep in a static array in the projectiles class, brings them all together, a circle above the player, and we release it, and the Skittles go everywhere. Okay, so just a quick review. There are a few things we hadn't discussed. So what behavior is happening on the screen right now that we haven't talked about in script yet, that we didn't cover in class?
I see a hand over there.
Oh, do you? Please. The camera. We have not talked about the camera yet, and that camera is also using the command pattern. So let's take a look. So first off, we have the world, and the camera is a camera 3D in the world. It is positioned around the player, but the camera's position actually doesn't matter a whole lot in the scene because we are immediately giving it a command. So just like we had player commands, the camera has a private camera command, and the camera command we're using is rotate and look at command. And then the reason why I want to show this off is because this is a command with duration. This command is meant to execute once every frame. This command isn't as ephemeral as a shoot command, which fires off a bullet and returns. This has information kept across time. So let's take a look. So here is the rotate and look command. It has four private variables that we care about. what the current rotation is. How many rotations per second should you be doing in radians? It has the height, so how far above the camera should it be? And then the rotation plane distance. So what's happening is the camera is up 7 in y, in the y dimension. And then the distance, that is the diameter that it rotates around in a plane parallel to the y-axis, to the yz plane. So it's rotating around the y-axis at a certain height above the character. And it is constantly being, its look-at direction is constantly being adjusted to the player's position. So let's take a look to see how this works. Is the code big enough? All good? Excellent, excellent, excellent. Thank you. So we have the execute command. Just like all the execute commands we've seen before, it returns a pool. We aren't doing a lot with the return values yet. That will come later. This execute command takes a camera and it takes a target, right? Because cameras exist in a place. This is meant to modify the camera's position and where it's looking at, but typically cameras need to look at something. So we're giving it a target to look at. Okay, so current rotation, we are increasing it by radians per second, and we have this long incantation here. Engine.getMainLoop.root.get process delta time. Anyone care to venture why we're doing this? Any thoughts? Yes. Exactly. We need to use delta so that we can move independent of the frame rate. But we're not in process. We're in some functions execute. This doesn't even really extend anything that's on the tree. So it's not getting the update cycle. But we can pop out to the engine and we can get a little bit of information from it. So we're looking at the root of the world tree that we are in, and we're getting that tree's delta time. So we're moving the camera consistent with delta time of our world. And so the radians per second is 0.5. And so we're getting a fraction of that based on delta time. Great. So we have a fraction of our rotation speed that we want to apply. So how are we applying it? Well, first we are getting a plane offset. So our goal here for this plane offset is to get a vector 3 that shows us where we are on that circle, that halo spinning around above us. We want to know where we are in that circle given our radians and the distance parameters that we've set. So right here we have the rotation plane distance. So we have the diameter of the circle, of that halo. And we're making a vector 3 where we're getting our effective x and y coordinates on the circle plane given some basic trigonometry. So x is eating the sine of the current rotation in radians. We're not doing anything with the y because this is rotating around the y-axis on above the xz plane. And so the z, we're using the cosine of the current rotation. Right. Does this make sense? Are you all tracking vector math and cosines? Just making sure. Sometimes it's inconsistent how much people know about vector math and how much people remember basic trig. But you're all awesome engineers, so and computer scientists, so I'm sure it's great. All right, so now that we have that plane offset, now that we know where on that circular halo we are, we want to start positioning our camera, right? So now what we want to do is take the global position of the target, just like we talked about earlier in class. We want to make sure we are syncing up our position across, independent of all of these local parent-child transformation spaces, all these local transformation spaces. So here we're working explicitly in the global. So we are getting our global position, which is a vec3. We're adding to it our height, vector 3. So this is vector math, right? So you add the x of one to the x of the other, the y of one to the y of the other, and the z of one to the z of the other, and make new vector with that addition. And because vector 3s are a core part of GD script, they're given functions built into the language, all of the mathematical operators are overloaded and appropriate for them. So plus works. And then, so we have the height, so we've taken the global position, we know where the character is, we're adding up to it, and now we need to add the x and y components, which are the offsets, the plane offset variable that we just calculated. And then finally, cameras have a handy look at function. So if you have a camera in your scene and you give it a position, it will rotate to have that position be directly in the center of the field of vision. And then we return true. So that's the basic of look at command. Let's take a look at the executable now with this in effect. So this could easily be interpreted as the player rotating. But the player's not. The player's stationary. So let's add a few of these, and let's do a nova, right? Notice that the skittles that are falling are rotating. From our perspective, they look like they're rotating. But that's not them rotating, that's the camera rotating around the central world. All right, so I wanted to go over a little more nuanced vector math with you with this camera. Do you have any questions about this? Yes? Does it say what function? Built-in function. Which is a built-in function? What are you talking about? Which part? Which function are you talking about? We talked about a lot of functions. Are you talking about this whole camera? Yeah. This is the code that I made for you for this camera. This is not built in. This is a camera controller that you can look at that I made for you to understand a little bit more about it. There are some built-ins. So the built-ins we are using to construct this function are this call to the engine to get the delta time, vector 3 sine and cosine, and the camera.lookAt. Those are the basic given functions in the core set of classes that we're using to compose this camera command. Yes? You can. That's a way to do it. Yeah. So there's a few ways to formulate this. So the question was why, so could we pass in delta as a parameter? We can. Maybe not every camera cares about delta. Maybe we want to add delta to a params object that we pass into it. There's a lot of different ways to handle passing that information into the function. Why I was doing this in the static way was to reduce the complexity of the command to make it easier to understand. Because it's probably the first time you've seen the command pattern in this project. So everything is distilled to be as straightforward as possible. Some of the Godot stuff is a little more complicated, but the actual pattern itself is isolated and I hope easy to understand. Does that help? Great. Yes?
I don't know if I missed this, but like what's the explicit definition of a command pattern?
All right, it's in the reading.
Okay.
So the command pattern is a software engineering design pattern to handle abstracting action bindings.
Okay.
So the command pattern is meant to treat actions or units of things that you do in a world or things that software can do into first-class objects. So you can pass them around and reassign them, and make new ones, instead of having those commands baked into like a large case statement or something. So we're adding the story of software engineering is this constant design of more abstraction and more power through making things more modular, right? And so this is what we're doing. We're taking things that are normally in spaghetti code, pulling them out into first-class entities that we can just ship around. You could use these commands in a lot of places. This is why I use target. and camera, right? This can follow any node. You could easily like add a command to this where you press the space bar and the camera would do rotate and look at around any one of the projectiles you fired. You just randomly pick a projectile at the right and the camera could center on it without changing this code at all. Right? So that's one of the power of the pattern. And this is the simple scratching the surface. So far you may not see the utility, but that's what the exercise is for. So we're going to push this into much more interesting places. Yes?
I wanted you to explain what the plane offset did, like conceptually, as in like what the sine of current rotation, what the cosine of current rotation did for the plane offset.
Yeah. So conceptually what the plane offset is, so we want the camera to travel around in a circle while constantly tracking the player. So if the camera was here, if I was the player, the camera should go around in a circle around me while looking at me. The plane offset is where it is along that circular route. So the plane offset, the plane I'm referring to is the plane offset by the height that is perpendicular to the ground. The ZY plane, or sorry, the XZ plane that is the ground in our world. Those questions, thank you, Nick. Yes.
So the whole purpose of accessing delta time is just to change basically changing the angle for current rotation, so that we're changing our angle in terms of the circle. Is that correct?
Yeah. So we want the change of where we are on that circle. We want that to be consistent over time. So what we want to do is move exactly 5 radians per second. So every time we call this execute command from within one of the other process functions, we want to know how much time is elapsed. How much of that 0.5 radians should we move right now from frame to frame, from process call to process call. All right. Did I miss anyone else back here? All right, any more questions about this? Clear as mud? All right, so let's just take a quick peek here at the camera controller. So just so you can, where this is called, it's a very tiny shoot command, projectile, player command, player, camera control. Okay, there we are. Right, so here, once again, we have this camera command object, which could take any camera command. Our rotate and look command extends this camera command object, just like our shoot command in here extended from the player command class. And here we call execute in delta, which, to follow this person's suggestion over here, we could modify this to also take delta time. Right? You just have to change the definition. So that means every camera controller has to take delta time as well. One more time with feeling. Just for fun. Okay. Fun has been had. At least I'm having fun. All right. Any more questions before we hand this over to Arunpreet for our exercise 1? Yes. Did I miss one? Oh, I'm sorry.
I
Yes.
have a question about the projectile.
Yes.
So since the projectile is a child of the player,
Mm-hmm.
when you set the linear velocity, is that relative to the player or the world?
So linear velocity is it's individual, right? That's how much energy has been added to a particular rigid body. So the direction of it, that's a good question. I'll have to look this up. I think linear velocity in this case is global, how we're using it, or else I'll get back to you on that. I'm not 100% sure. I don't want to give bad information.
Because like I was wondering
Yeah,
if
it's a good question.
instead of the camera rotating, if the player were to be rotating, if it would still have the same effect.
Ooh, that's a good question. Let's find out.
So what was the question?
Let's rotate the player a little bit and see what happens. Oh, there it is. So it's global, right? So it's not low. No, it is.
Did you also shift the spawn?
No, I did not shift the spawn. So the spawn is on the end of the we're getting the global position of the spawn on the end, but now we rotated it and the projectiles are spawning as they were before. Right. Yeah. Yep. Which is important. You'd want to do that before like you move the character around. Right. So this is a thing that has not been exposed yet because this is a toy. But thank you. I will make that correction. All right. Any more questions? Yes. Why we need new after the command. So let's go to scripts. This right here. Because rotate command is a class definition and you want a new instance of it. Yep. Yes, this is how you create instances. Instead of the new keyword being before a class name, this is how Godot script does it. You take a class reference and it's basically there's a static function called new that calls a constructor. All right, any more questions? All right, we need to move on now. So Arunpreet, I will open this up while I give you the microphone.
Oh, I have a microphone? Do I have a pocket? I do have a pocket. Let's go.
Just turn it off for now. You can turn it back on.
Cool.
Oops.
Hello. Hello, 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 hello. You all wave again, that's wonderful.
If you want to introduce yourself, and
Oh, yeah.
that'd be great too.
So hi, my name is Arunpreet Sandhu. I'm one of Josh's PhD students. I've been here for a little bit, so about 7 years. I have seen some familiar faces here, so hello, hello. In terms of why I'm here, so originally I believe I was supposed to be the TA for this class. However, there was a little kerfuffle in the background. Instead, I am here to help out. Oh,
Just be near the microphone so we get the
Oh,
recording. There you go.
fantastic. Again, hello to everybody who's watching the recording, if there is a person who is. My name is Arunpreet Sandhu. Due to that, I was assigned to fill out exercise 1, and I'm still working on it. We're still figuring out a little bit of a kerfuffle in the back end, so that's the reason why it's taking a little bit of time to get to you guys. So Josh has asked me to come in today to talk a little bit about exercise 1, and more importantly, just kind of like how to start building maybe the template of a game. So to get from the beginning screen of Godot to all the way here where, is it okay if I play it real quick?
Yeah, absolutely.
All right, fantastic.
You're in control.
All right, so if you just do a little play real quick, to having a character move across screen like such, you have a jump command, and then you also, on top of that, have NPCs in the background that are running around, and then eventually change direction as well. A lot of this is being ran by the command pattern. However, there's something that currently isn't, which is the camera controller, or the camera, I should say, which might switch over to the command pattern, and I might ask all of you to implement that as well. That would be fun. Well, for me, at least. I don't know if it's fun for everybody here. But, okay, so in terms of talking about this, so what would you like me to go over? Do you want me to just start from like the bare basics of like adding in nodes, or?
What is the core node of the world?
Okay,
What
yeah.
are the basic objects?
Cool.
And then go through them and tell us how they're made.
All right, perfect. Okay, so when you open up this assignment, you're going to get this scene right here. The scene itself is called main.tscn. I believe that's how Godot does its scene naming. But basically, this will be effectively your main function, at least within the Godot editor. Within this, we're going to have this root node, currently called node. I don't have anything fun named for it like world tree, but we have node up here. Then after that, we have our tile map layer. Now what we didn't want to do that. So the tile map layer, what this effectively does, it opens up this new layer where you can actually add in tiles to your tile map. So if I wanted to, I could just grab these down here. So what I'm doing is I'm selecting this option within the tile map view. If this view does not does not show up when you put in your tile set, which I'll talk about how to actually add in a tile set as well, you'll just click down over here, click back up, and then you can have your tile map. Now when you're in your tile map, you can just start painting around whatever stuff you want. So you could just easily do this. And of course, we have our friend Control Z. But in terms of how to actually get to your tile set, the way that you end up doing this is you'll also get this nifty thing over here for tile set, and you can add in other images, other PNGs if you'd like to. Oftentimes, so right now, currently in assets, we have a bunch of the assets. So we have Bringer of Death, who's the boss character that you'll fight at the end of this. This was the original scene. So this is a parallax background that you can use, which we'll get into what parallax is in a second. Follower, so this is the little critter that we saw earlier. And then we have Genshin-inspired background. So if you saw the background here, the parallax background right now is actually, it is an inspired thing from Genshin. There is also a Genshin tile set in here as well. So I don't know if I will be updating the scene to incorporate the new Genshin tile set, Genshin-inspired tile set, I should say. Or if that could be something that y'all could do as a part of your stage 4. That is, of course, up to Josh, though. He and I will talk about it, and that could be something you guys can do. Do they know the structure of the homework assignment, what stage 4 is? Okay, I will get into what stage 4 is as well. Cool. Okay, so as I was saying, we have this tile map, we have this tile layer. So if we go back over here, in terms of what the tile map layer is, it's just a node. So if you just do Control-Shift-I, I think, or Control-Shift-A, that's the wrong one. If you do Control-A, you can bring up your nodes over here, and then you can just type in tile map, and you'll get this tile map layer down over here. This is what you would add to your scene if you want to go ahead and put in a tile map layer. Any questions so far?
How many of you have done this through the tutorials? Tile map stuff.
Oh, sick.
Not everyone, but a lot.
A goodly amount. Sick. Okay, then I'm going to go ahead and move over to the next part here, which is just going to be talking about adding in collision detection for the tiles. I'm not going to try to spend too much. Who here has added in like collision to your tiles? Raise hands. Hi, please. Hi, please. Hi.
Yeah, maybe a third.
A third? Okay, I'll talk about it real quick just in case if this is something you guys want to do, or if you just want to make 2D games within Godot. So the way that we go about doing this is, if I can remember correctly, is let's go ahead and just increase this a little bit. When you guys have these options over here, so you'll see your tile set. If you click on any of these guys over here, I believe there should be a select. Is it in here? Select. Okay, cool. So you select the select tool right here, and then you can click on any of these tiles down here. And if you go over to physics, you'll see your physics layer. Now, what physics layer lets you do is it lets you go ahead and add in this little red guy right here. This just is basically saying like where you can collide. So a perfect example of this is if I were to go over to these tiles that I know that are currently with their collision, and if I were to remove them, which I believe I can do with just deleting this, or
You can just sag it a little bit too.
what was that?
You can just sag it.
Oh yeah, let's just do that instead. Let's not delete everything and then make it a little harder for everybody else. Let's just go, okay, we're gonna do that. Cool. So this one should be it. Hold on, it actually might not be. So let's go ahead and bring that back real quick. If you're ever confused about like what tile you actually have, if you go back to your tile map, you can go to select over here, and I'm pretty sure you can select which one this is, and it should let you know, boom, right down there. So if you're ever confused about like what tiles you're actually using in the scene, go over to your tile map, use your selection tool, and then you can just copy it and it will show you what you're using. So I'm currently using these 4 to make this pattern over here. So let's go ahead and just change one of these. Let's go back to tile set, and so I believe this was one of them that I was using. Let's go over to the physics layer, perfect, and let's go ahead. I'll just remove these for right now. So like that. What's up? Is that not the middlemost one? All right, cool. And then if you play this now, what ends up happening is I kind of go a little bit further down.
Thinking.
A little bit further down. And if I were to remove the rest of them, so like if we were to go to this one, I think, remove this one as well, it would sync even more. I'm just going to demonstrate it just in case because why not? I feel like this is good for repetition anyways. So now we should go even further down. Cool. Okay. So this is how you can, and then if you want to add back in the, what is it called? The collision layer, you can actually select both of these. So you can just do a shift and then do Control F, I believe, Control F, Control F. Okay, just hit F. F is the key that you would use here. Or you can just simply add it back in here, and I think there are specific nodes, like add polygon tool. So yeah. Important note here is that if you do have irregular shapes in here, you can also just go up to them wherever they are. So let's say that we don't have any irregular shapes in this one. That's fine. If you do have irregular shapes, you can modify the collision here using the polygon tool. Cool. Okay. Any questions about that? Perfect. Okay. So that is how you can add in just a very basic tile map into your game. Now you're probably going to want to put characters into your game as well. So the characters themselves, I'm actually going to go ahead and remove the parallax background right now, just so that way I can remember to talk about it in a second. Instead, what I want to talk about next is our characters in the scene, such as player, boss, and follower. In terms of where these characters are, here's our player, over here is our character, or our follower, and over here is our boss. So the idea of this assignment is to hopefully introduce you to the command pattern through moving your player, then having your player jump, and then going from jumping to try to convince this little guy, this little dino guy over here, to follow you. After they follow you, you then go up to the boss. There will then be a cutscene that is executed through commands. So we will have a command queue via command patterns, I believe. There will be a full-on readme with an explanation of how each one of these goes. And then finally, for stage 4, so stage 1 was moving the character, and I believe jumping, correct?
Yeah.
Stage 2 is going to get the follower to follow you. Stage 3 is going to be the cutscene through commands, so using the command patterns to create a cutscene. And then finally, stage 4 is a boss fight of your choice. So you get to make your own commands and your own patterns, if you'd like to, in terms of how you want the boss fight to go.
We'll give you certain minimums that you have to accomplish.
Yes.
This will be something you can apply your own design wit to.
Like ideally, like you want to do the boss fight using only like using commands. If we see code, or I guess I don't know. I actually, this is weird. I've never been on a TA for this before, so I can't say anything. Okay, there will be minimums, as Josh said. I don't know what they will be actually. Okay, but yeah. So again, stage 1, moving character. Stage 2, getting a follower. Stage 3, cutscene. Stage 4, your own boss fight. Cool. Any questions about that?
Right.
So we have to implement all these stages for the first assignment?
Yes.
Yes. Will it be
I
posted
didn't
in
hear the
Canvas?
question. Can you repeat it so that you can hear it online too?
Oh yeah. Will the assignment be posted in Canvas?
The assignment will be, you will get the link to GitHub Classroom in Canvas. In GitHub Classroom, you'll go through that and it'll generate a repository for you. And then that's where you'll get the code. I'll also show you where the template repositories are so you can just look at a canonical version. Right?
And there should be, hopefully, once I am fully done with building out the solution set for this, I was mentioning this to Josh, I don't know if this is still going to be in plans, but a possible small little demo video just kind of showing my implementation without any of the code, but just like a run through of the game and me talking about each of the different stages. That's still a possibility, but yeah. Cool. Any other questions? Yes?
What will the submission look like? Are you submitting code or is it going to be like a video?
That's a great question. You will be submitting, and Josh will correct me if I'm wrong, you'll be submitting your own GitHub repository with all of your Godot code in there, and it should be playable by your peers, because have you talked about the peer review?
Yes, roughly. We talked about peer review.
Okay, because the idea here is that your peers will be assigned to your assignment, and they will be able to play through your game via the Godot editor. If you want to go above and beyond, you can make an executable, but at the core, there needs to be the Godot code that anyone can use with the Godot editor. So hopefully this will just be using GitHub and pushing up various GD script files. That should be like ideally what you'll be doing for this.
I can put a slightly finer point on it. In particular, we'll be grading whatever's in your main branch
Oh.
that you push up to your GitHub repository. And that's what your peer reviewer will be reviewing. Right, so we're keeping as simple as possible protocol for this. But we'll go through and give you a more detailed explanation when when the assignment's actually released.
Cool. Okay. Yes. What a great question. So ideally, by the end of the discussion, I should have explained enough where you can go ahead and implement your own assets. However, I think at the minimum, we might want to use these assets just to make sure it's standard. However, your stage 4 could possibly be implementing a more complex follower with your own assets if you'd like. But that, again, I'm not the one that can determine this. That might be a Josh thing. So actually, yeah, can they use other assets?
Yeah, generally I'm fine with using whatever assets you want, as long as it doesn't make the project file too big. And in particular, stage 4, like if you wanted to go really crazy on the boss fight, and it could be like Spider-Verse where you're hopping around dimension to dimension, so you're changing tile maps and sprite packs, adding in sounds. This is the part where you get to have a little fun. Yeah, and generally I'm happy if you want to change the base sprites too. You just have to make sure your peer reviewer can understand what the heck's going on.
So if you do that, just make sure to like put a follow-up like right up, just like, hey, these are the things that have changed. Cool. Any other questions? Very cool. Okay, going on from there, let's go and talk about characters and maybe just explain how you might be able to build your own asset. So coming back to it, as I'd mentioned, we have the player character over here, and we're just going to go do a little bit more of a deep dive in the player, or at least one of the character sprites. That way we can talk about it. Now, the way that I ended up coding this is that I have the scenes folder in here, which I believe everybody will have access to, and we'll have this boss scene, this character scene, this follower scene, and this player scene. The way that I ended up doing this is I created a base scene called character scene. Now, if you notice, there's nothing in character scene except for the character body 2D, I think that says controller node, which is actually a deprecated thing that I need to remove, and that's kind of funny that I just noticed that right now. You gotta love what you find in production. The animation player, which I will be getting a little bit more into, the collision shape 2D, as well as the sprite 2D. Now, this is just the base character class that all of the characters extend from. So here, if we go into our boss, we can see that we have the boss sprite on here via the sprite 2D. We have the collision shape on there, which is the little guy behind there. So let's see if I can move it so you guys can see it. So this right here should be the collision shape. And then the animation player. So I'm going to go to the player character real quick so that way I can talk a little bit about how to use the animation player, because this is going to really let you make your own assets if you would like to. So when you're adding in a sprite 2D to your character, you're going to go to sprite over here, and you're going to drag and drop it over here. So if you notice right over here, we have what is a sprite sheet. Within this sprite sheet is going to be all of the various character animations that were the various frames for our character animation, I should say. Now, currently, right now, within this, we have a few. So we have attack, so let's go ahead and zoom into the character right here. If we play this over here, we can see the attack animation. Notice that it is not looping. If we then go over to something such as move, when we go and click this, we can see that the character is running, and now it is constantly looping, as you can see within the timeline. There we go. Timeline down here. It's just constantly looping over and over again. And if we zoom in on this, which if I can remember the command for this, we can see all of the frames that create this animation. Now, in terms of actually creating a new animation, the way that we go about doing this is we go over here to animation and we click new. When you click new, you want to name your animation. Don't worry, you can change this later. Right now, I'm just going to go ahead and call this test, and you hit enter. Now, what you're going to get is this brand new timeline track. What you want to do here is you want to hit add track. You're going to add this property track. You're going to go over to sprite 2D. Okay, you want to go over to sprite 2D and not miss because you're not used to the mouse sensitivity. And then you want to select frame, specifically frame. And the reason why we're choosing frame here is because we want to be able to index the sprite sheet. Cool, okay. Now, in terms of actually figuring out what frame you want, you're going to be coming over to your sprite 2D, and you're going to see your animation over here. Now, I've already set this up for the H frames and the V frames. Those refer to your horizontal frames and your vertical frames. In terms of actually setting these up, that says 16, 6, and 17. I'm going to forget that. We can Control Z. I think this should be fine. Let's go ahead and reset these so you can see what a sprite sheet ends up looking like when you add it in. So when you first add in your sprite sheet, if you notice, we get every single frame in here. And the reason for this is because we haven't properly indexed the sprite sheet using the vertical frames and the horizontal frames. In terms of getting each one of these, what you'll do is, it's pretty straightforward. You'll count the horizontal frames that you have within this matrix and the vertical frames that you have within this matrix, and then use those numbers accordingly for the H frames and the V frames. So if we go back over here, I'm going to do Control Z to get the 17 frames, so just to make sure everybody knows where this number is coming from. Here, let me go to make sure that I don't mess up anything here. I really am not used to high sensitive mouses. You can really tell I don't play video games. Cool. So in terms of the vertical frames, the way that we get this is we just count these up. So we have 1, 2, 3, 4, 5, 6, 7, and Josh is coming over.
Oh, you
here.
can change the DPI with this toggle right here.
What?
Down and up. It's hot. It's got hot
Oh.
DPI.
Perfect. I need that super slow. Thank you. Perfect. All right, so as I was saying, so we got 1, 2, 3, 4, 5, 6, and let's pretend that I counted the rest of these and go all the way down to 17. So that is how you get your vertical frames. In terms of actually getting your horizontal frames, it's pretty straightforward. You count the horizontal amount here. So we have 1, 2, 3, 4, 5, 6. So let's go ahead and put the 6 in there, like so, and bam. Now, and the reason why we went through all that is because now what you can do is when you go over here to your sprite 2D, you'll notice that you have frame down here. What frame lets you do is it lets you go through each of the frames individually. So if we notice, I can start going through these, and I can go through the first one over here. So let's just do, okay, let's go through the first one. So you can just click through, and you can't really see the animation. So let's scoot on in, and we can go through the individual animations and see where these things start. Now, the one thing I'll mention here is this is like a little bit of a pro tip, or not like a pro tip, but just in terms of working with sprite sheets, oftentimes you're going to want your sprites or your frames to be normal, more or less, where you know where the beginning of the animation starts and the end of it. Usually you'll talk to your animator for this, but alas, we can just look at the sprite sheet. So we can go through here and bam. Now, I saw an animation that I haven't done yet, and the way that we figure this out is we can go back over here. So let's see here. I've done run before. We've already done run. Let's do the climbing one. So the way that you end up doing this is you go to the very first frame that you have here. You go over to your timeline. You can right-click, and then you can insert key. Now you can go to your next frame over here and do the exact same thing, bring it over here, insert key, and then continue doing so until you get to the very end of the animation. So let's pretend that I've been adding in the keyframes this entire time until we get to the very last one. And then we can just insert key over here, and bam. Hopefully more of these animations are going to be in the game, so that way you guys are going to be able to work with them for your assignment. I'm not going to go through the process of completing an entire climb scene just because we don't have anything we're climbing on within the game.
Yeah, we got 7 minutes left.
Oh, do we really? Wow. Okay, so to get back to the question of assets, this is how you'd go about like adding your own character if you'd want to. Because now, after this, in terms of adding in some code that you want to work with, you'd go up to your character body 2D. So actually, yeah, let's go back over to character real quick. So if we go back to character, you're going, and we scroll all the way down over here to node, you'll see that there's this script called character.gd. If we click on that, we're going to end up getting the base class for character right now, and I can barely read that. Is there a way to?
Control plus plus, or control plus, to make it bigger. And then we can also
Cool.
do this and unextend this.
Perfect. And if you notice, there's a fix in there because I need to make sure that this follows the style guide before I give this out to you, everybody. So right now, within this code, it's very basic stuff in terms of how to move all of the characters. So we have our walk speed, our acceleration speed, which should honestly be velocity, but hey, we're going to name that later, hence the fix. If we scroll down here, we're going to see what's kind of the most important part for the assignment. This right command, left command, up command, fire 1, fire 2. And each one of these is a command. So what commands actually are, how can I find this is where I own up to the fact that I use an external editor the entire time. How do I get the editor again?
It's right here.
Perfect, thank
You
you.
can just use this.
All right. So in terms of what the commands are, now you're not going to be getting everything. So commands are going to be within the script. So if we go over here to scripts, you're going to see the character script that we're currently on, and there should be a subfolder that will have the commands as well. I'm not going to click on most of these because there is code that is valuable for your assignment, so I don't want to do that, but I'm going to go to the command.gd. So the command.gd is going to be the base class that you'll be extending from for most of the assignment. There are some things that might change up, but however, you will have some sort of class that you will be extending from, such as the command. Now, I can't remember. I'm allowed to show them one of the commands.
You can move right.
Move right? Okay, fantastic. So let's go pop over to move right, so that way you can see what it kind of looks like. So in move right, we go ahead, we have this movement command. It extends from command. We have that the execute function, and currently there's just a character, and then we're moving it. Notice here that it says acceleration speed, and then we're setting the velocity to acceleration speed. That doesn't make sense. Again, a little bit of deprecated code. That's why we have that fix in there. Now, if you notice, there is this flip H over here. that's called false. The reason for this is because if you notice within our character, so let's go ahead and go back over to our player. If you noticed within our player, if we were to look at the sprite sheet again, let's go ahead and just find it somewhere. We're gonna do this. I can't read. I am so sorry, everybody. Oh, that explains everything. If we go back over to the original frame and we kind of go through and scrub through these, you notice that we don't have any move left. Now the reason why I'm doing that sprite flip is because there's a way we can flip sprites to maybe get left movement. I'm going to leave that up and not actually explain what goes on further than that because I believe you'll be implementing your left movement command. How am I doing on time, by the way?
4 minutes left.
4 minutes? Crazy. That's crazy. Okay. So I know this was kind of a rush, but in terms of like, if you want to go ahead and extend this and add in your own characters for like, let's say a stage 4, you can extend this character class up here and then just create a new character such as that we see here in player. So I think I can show you player. So if you notice here within the ready function, we're assigning the commands to something different. So we have this right command, we have this left command, up command, fire 1, fire 2. It is right movement, left movement, jump command, attack command, and follow command. This does not need to be the way that you end up, or I guess some of this has to be the way that you end up programming it. But you can work with these commands. Now, there's something important that I kind of have glossed over that I should mention, which is this input over here. So if you notice, we have input. When you're assigning input into a Godot game, what you'll need to do is you'll have to go over here to project, go into project
We
settings.
covered this in class.
Sick, I don't have to talk about this. Cool. Okay. So yeah, at this point, this is kind of where your assignment starts. I would say is that you would end up creating your own player class. We're not going to be giving you all of these. I'm pretty sure we're only going to give you the right command. So
Can you
your
talk about the difference between player controller, cutscene controller, follower controller?
yeah. Okay, so like all three of them, right? So
yeah.
play-
And how, like, each one of them, the stage.
Oh.
Each one of them are associated with the stage.
Okay. So what you're looking at right now is like the player class. This will probably morph into what is called the player controller at some point. So much like the camera controller that we saw at the beginning of class, the whole idea with the player controller is that this is what you'll be using for stage 1, stage 2, most of the stages actually.
This is where human does the controls.
This is where human does control. That is such a great way of saying that. In terms of the follower controller, so then after that, so for your stage 2, your stage 3, and your stage 4, you'll have your follower controller. The follower controller is how your code controls the character itself. So you want to have, much like the camera actually, I'm thinking about that. Much like the camera, it's going to be programmatically. So rather than having
Remember the
inputs.
Skittles project.
Yes, the camera and the Skittles project, exactly. Rather than having input, it's a lot of that's going to be code. So like you might program something like check the distance between two characters and see how close they are. If they're far away, maybe follow. Or a motivate command, such as if your follower isn't motivated enough, you might have to motivate them. And they might show that through an animation or something like that.
Yeah.
What sorry, is that?
Yar.
Yar. And then after that, we're going to get to the cutscene controller. So the cutscene controller, what we've been building up to this entire time, is this notion of commands and running all of these characters through the commands. And just other objects within the scene, such as cameras as well. So the idea with the cutscene controller is that you'll use a command queue or some sort of command pattern, or a pattern of commands, I should say, to execute multiple commands for all of the characters within your scene that then play through a cutscene. There should be a little demo of this explaining how this works. And this is kind of the I don't have a good metaphor for this other than to say secret, of how games end up hijacking your player character so that way you can start a cutscene. It's because they remove the player controller and they put in the cutscene controller. And it moves the character itself. And then finally, for your stage 4, it's going to be kind of up to you. It's a mix of how you want to run it. I think I'm out of time. It's 7.
You're going to make a boss fight, make a bunch of commands with a boss fight controller. And I want to play these, so I want to fight your bosses to make them fun. All right. Turn it
Sorry
off.
for going.
All right, everyone. Thank you for your time. I'll be heading over to the Game Dev and Arts Club for anyone that wants to join. And I will see you all soon. And I'll hand out the assignment as soon as we possibly can. Thank you. Have a great night, and I'll see you on Thursday.
What's the question?
When is this due again?
A week after we assign it.
Okay, thank you.
Yeah, there's hopefully it will be either Thursday or Friday at this point, I believe, and so you'll have the entire week. It's based on.
How goes it?
Hi.
Could you go over the concept of a controller again?
Yeah, it's the thing that controls what a character does. It's the thing that makes the decisions on what something in the scene does.
So,
For instance, the player controller takes the input from like a controller or keyboard and mouse and moves the character accordingly. The NPC controller uses some sort of algorithm, probably some case statements, to control a character.
That's what you meant when you said the cutscene.
Yep, the cutscene's going to hijack all the controllers for all the characters and sequence them so that all the characters will do something relevant. Like, we're going to put like a dialogue. There's dialogue in it you can put in sequence, and you'll have some movements you can do.
I read the command pattern thing, but I didn't quite understand it fully. So the idea is we're making these like objects for every single command we're doing, so that we can separate it from hard coding like the actual inputs. Right?
Yeah. So what you're doing is breaking the association. You're making the association between input and command
Josh, could I get the,
abstract.
I'm gonna take this. I never explained parallax background. And
I
somebody
just
asked a
turned
question.
off the mouse. Let me
Oh.
turn it back on.
Yeah, sorry. I'm gonna just show it real quick.
Did I turn off the keyboard as well? Nope.
Cool. So the way that we do this is when you go over to parallax background, you can just
Separating it.
let's go ahead and go to the scene. So the way that this works is it's pretty straightforward. What you're going to go ahead, you have this
So
parallax background.
this is becoming
It is a
abstract.
note, yes.
Right?
If you
So
want to
we're-
add this,
we're
you
making
go
it
control,
first class so
and then
that
you
you can
type in
pass these things
parallax
around. You
background.
can make new ones.
Now, what's very
You
important
can,
about this is that there are
while the
three
game is
different
running, switch which ones are bound to which commands.
parallax background, sorry. So
Right?
there's
Which you couldn't do if they were in a case.
parallax 2D.
And now we're taking that power to the next level with controllers.
So what you want to use is the
So
parallax
we have
background.
all these
Sorry,
commands that are
it's
bound to
effectively like a
buttons,
tile
just like
map.
we had with the shoot command and the
So
collection.
once you get this, you will then go and set that up. You will then go over to your parallax
We
layer.
can start treating them as first class entities. So what we're
Right,
doing
right, right. That's a
with
great
the,
question, right?
with
The
the boss
reason why
fight
is because if
is
you
you
want
actually
to add
making a
in,
bunch
so
of commands
usual
and then you put them
parallax,
in
I'm actually going to go ahead and show
make
you
one command to go. like
with, okay,
jump.
maybe not.
Okay,
I will
after you
try
jump
to
to a
have a
certain
more
height,
in-depth
You can
explanation of
return
this
false.
in the demo
That's
so
why
you
there's a
can
Boolean
see it.
returns.
But so
That's a
idea
signal to
is
the
that
controller to move on to
we
the next
don't- so
command in
the
the queue, which could
parallax
be
background,
shoot.
right? Let's
And
say
then
we have
you
three
have
different
maybe a
images,
wait
right?
command, which fall to
Well,
the
let's say
ground.
all three of them need
You
to,
can fall to the ground, then you can have a move right
scale differently.
by
So
30
if you want to
pixels
scale
command.
1 to 1.2, then to 1.4,
And
then
then
to
that would be
1.5.
over after you've hit
Right?
your target, and then you
So
can
we're
jump
going to need to
back,
have three
right? So you
different
can make
layers
this
because
Mega
we can't
Man
control
style,
those
Rock
in the
Man
back.
style boss fight.
Does that make sense?
Got it.
Cool. Okay. Then after you create this parallax layer, you
That's just simply
use
to
the sprite
order a
2D.
bunch of commands.
Once you have the sprite 2D,
just
you
some
can
structure
actually
to
add in the
order
sprite that you want to
with
use.
a bunch of
Sprite 2D
commands.
is literally
instances-
just the
command
whole
instances.
PNG.
Yes, this is the whole PNG.
Got it.
Now, if you notice, though, what I have going on is I have this.
Well, you're
this
building up to that,
mirroring.
right? You're going to have a bunch of
So if you
stages
notice,
to get
there
there.
are these two
Then you have
images.
the code
So
and
the
the
way that this
scaffolding
ends up
from the
working
assignment description.
is when we
And
go
a bunch
over
of
to our
box covers.
parallax background, if I
These are
remember
not meant to be
correctly,
trivial
we go over to
assignments.
transform, if I remember
Although the
correctly.
first
No, it's actually
two
in
stages are
parallax
going to be
layer.
pretty
So I
darn easy
apologize.
code-wise.
If
We're
you
trying
notice,
to-
I have this
to wrap you up.
2048. You might be wondering, where did this number come from, right? The answer
Good luck.
is it comes from the sprite 2D over here.
We'll give you as much
So
help
if
as
you go
you
to texture,
as
and
we
click
can.
over here, you'll notice that I have this, this 2048. Now, if I wanted to add more to this, what I could do is I could just go to Control A over. I can hit Control A. I can go over to the parallax layer. Did you?
Oh, go ahead. I'm just going to stop the recording when you're ready.
Cool. You'll go over to parallax layer over here. Notice that it added the sprite 2D. Don't do that. Instead, what you want to do is you want to bring it up here. And we're just going to go ahead and add in another sprite 2D. Sprite. I don't know how to spell sprite. Sprite 2D. All right, cool. Now. Sorry, what was that?
You're gonna add another scene.
Yeah, exactly. And we're going to go to this country village over here. And I'm going to go to this parallax background. And what I'm going to do is I'm going to grab, I don't know, let's do cloud. Let's do black tree, because I know that this is an actual tree. I'll drag this over to texture right here. You can plop that in. Now, if you notice,
Now the problem is the Z value.
the Z value?
Yeah.
Right. And the way that we can deal this is you can just grab this. I'm pretty sure you can just grab the sprite 2D and just drag it down like, okay. You can just drag it down like so.
I think they also just do render order too, like in the tree child
Really?
sibling order. I remember correct from.
All right, let's run this again. Oh, it's yelling at me, and the reason why it's yelling at me is because there is a space here. Yeah. Dude, spaces and tabs have been my nightmare. I know this.
Welcome
very,
to Python programming.
Yeah, Python. All right, now if you notice, it's not moving, right?
Yeah.
And the reason why it's not moving, the reason why it's not mirroring specifically is because what we need to do is when we go into parallax layer 2 right here, we should go to transform, and there should be, okay, wait, hold on, where is it? Mirroring. So we have mirroring over here. So the way that we can do this, now remember, we had one number that we used, the 2048. Let's go ahead and use that number, why not, right? 2048. I'm setting us up for failure, but I think through failure we learn. If you notice, it's still broken. It's not doing anything. Well, turns out actually we did add a mirrored image. It's over here. The problem though is that we're layering it, or sorry, we're trying to get the mirror at the 248, which we see over here with this sprite 2D. If we go here, 248. But that's not what our second sprite 2D is. Our second sprite 2D, if we click on this, is going to be 384. So if we want proper mirroring, we need to go ahead and use 384. And bam, it gets over here. And now if I'm correct, when we play this, we're going to get, okay, well, you know, okay, it's a little goofy, but it works. But the real core that I want to explain is the reason why we're using these multiple parallax layers is because we can do something like this. So we could have like one thing be 2000, you know, like almost 2K, and then we could have something else at 1K, and then we can move them differently. Does that make sense?
But there's a dumb way. You just copy them manually. Put there.
Yes, you could do that, but this is
okay. This
Yeah, there's a lot of details with the parallax algorithm that you have to handle.
Yeah,
What
dude.
depth it is. So if you look at some old video games, some of them handled parallax very poorly,
Yeah.
including going the opposite direction they should be going.
Okay.
And this just makes it a little bit drag and drop easy.
You're right.
Cool. If you have any more questions,
You can
feel
write your
free to.
parallax algorithm if you want.
Yeah.
This is actually new to this version of Godot, is the parallax for the parallax types. So they're probably a little buggy.
I didn't give them my contact information. Is there a way that I can just let them know?
Hop
they
on
can reach-
Discord.
All right, cool.
You know how to
I'll
get there.
just Say hi to everybody there.
You're still active.
Yeah.
Yeah. Thank you.
Cool. I'm gonna go ahead and message Discord tonight, so I'll put it in the channel. It's okay. My name's Arunpreet Sandhu. And so if you have any follow-ups that you want to ask me, feel free to reach out.
Turn the whole thing off. Shut system down.